So this is divided by 1 by gx. So this function numerator divided by 1 by gx, that is same as multiply by gx. So that it get converted into 0 by 0 or infinity by infinity form, and then you will apply L'Hospital rule to this. Applying L'Hospital rule, find out the derivative of numerator, find out the derivative of denominator function, and after applying the limit, if this limit is suppose b, then we get log of L is equal to b, and from this we get the value of L as e raised to b. Okay, e raised to b will be the answer. This will be the limit for the given example. Okay, so we use the same procedure for these two remaining form, 1 raised to infinity as well as infinity raised to 0. So we consider examples now on this. So already we have solved problems of the 0 raised to 0 form. Okay, we have covered example of 0 raised to 0 form. So again we consider one more example on this 0 raised to 0 form. So consider limit sin x raised to tan x as x tends to 0. Okay, so first of all identify the form of this problem. See the form. If you put x is equal to 0, this becomes sin 0 raised to tan 0. Now we know that sin 0 is 0 and tan 0 is also 0. So given example is in 0 raised to 0 form. So how to solve this? So let's assume that L is equal to limit of this sin x raised to tan x. In the next step, we will take logarithm on both sides. So take log of both sides. So we get log of L is equal to limit x tends to 0 of tan x into log of sin x. Okay. Tan x multiplied by log of sin x. So that here tan 0 is 0. So this is 0 and log of sin 0. Sin 0 is 0, log of 0 is infinity. So now this is 0 into infinity form. See that 0 raised to 0 converted into 0 into infinity form. Now write this function tan x in the denominator so that log of sin x function in numerator as it is. We divide this by 1 by tan x. Okay, and 1 by tan x is nothing but cot x. So we can write this as log of sin 0. Sin 0 is 0, log of 0 is infinity, and 1 by tan 0. Tan 0 is 0, 1 by 0 is again infinity. So now the form of this problem is infinity by infinity form. By putting x is equal to 0, 1 by tan 0 is 0, 1 by 0 infinity, and this is infinity, log of 0. So infinity by infinity form is there, and now we will apply the L'Hospital rule to this function. Okay. So for this 1 by tan we can write cot also. So this can be written as cot of x. 1 by tan is nothing but cot x. Now we will find out the derivative by using the L'Hospital rule. Limit x tends to 0. This is d by dx of log of sin x divided by d by dx of cot x. Now find out the derivative. Simplify this. Limit x tends to 0. Derivative of log of sin x, that is 1 upon sin x, into derivative of sin x, that is cos of x, divided by divided by derivative of cot x, that is minus cosec square x. Okay. Now you put the values x is equal to 0. This becomes cos 0 is 1, sin 0 is 0, and cosec square, that is 0. So if you simplify this, you will get 0 value. So log of L is equal to 0, and this is our b value. Right hand side value is b. So this is our b. And if this log of L is equal to 0, so L will be e raised to 0, and this is equal to 1. Okay. So by putting x is equal to 0 in the right hand side, we get this limit as 0, and log of L is 0, so L will be e raised to 0, that is 1. Okay. So in this way we can solve the problems of 0 raised to 0 form. Now we use the same procedure for solving problems of remaining two form, that is 1 raised to infinity and infinity raised to 0 form. Now consider the example. Limit cot x raised to sin x, x tends to 0. Cot x raised to sin x as x tends to 0. Now see here, if you put x is equal to 0, this becomes cot of 0. Cot of 0. Cot is nothing but 1 by tan. Tan of 0. And tan 0 is 0, so 1 by 0, this is infinity. So this value is infinity. And what about sin 0? Sin 0 is 0. So this is infinity raised to 0 form. Okay. So given problem is in infinity raised to 0 form. So how to solve this? Similar like 0 raised to 0 form. So let L is equal to given limit of this function. Then in the next step, taking logarithm of both sides. So we get log of L is equal to limit x tends to 0 of sin x into log of cot of x. Now see that if you put x is equal to 0, this becomes sin 0. Sin 0 is 0 multiplied by log of cot of 0. That is infinity. Okay. So this is now converted into 0 into infinity form. Now we can solve the 0 into infinity form by reducing it into 0 by 0 or infinity by infinity by shifting this second function gx in the denominator. Keep the log function in numerator. Second function gx, we will shift this function in denominator. So we will write this function divided by 1 by sin x. Limit x tends to 0. This is log of cot of x divided by 1 upon sin x. Okay. And now see, after writing this function, divide by sin x, that is same as multiply by x. Okay. Question will remain same. But the form will change. So here, this become 1 by sin 0. Sin 0 is 0, 1 by 0 is infinity, and this is log of cot of 0, that is again infinity. So now the form is infinity by infinity, therefore we can apply L'Hospital rule to simplify this. Okay. So for L'Hospital rule, we write this function as limit x tends to 0, log of cot of x divided by 1 by sin is nothing but cosec x. Okay, and by using L'Hospital rule, we will find out d by dx of this log of cot of x and d by dx of this cosec x. Finding the derivative of cot x as well as cosec x, we can simplify this right hand side. Okay. So this is equal to limit x tends to 0 of derivative of log of cot of x. So this is 1 upon cot x into derivative of cot x minus cosec square x divided by derivative of cosec x minus cosec x into cot of x. So see here, 1 cosec with this 1 cosec get cancelled. 1 upon cot into cot, that becomes cot square x. So limit x tends to 0. This is 1 upon cot square x multiplied by cosec x. With minus sign, minus that becomes plus. So in numerator there is cosec x divided by cot square x, and if you put the value x is equal to 0, 1 by cot square is nothing but tan square multiplied by cosec, that is sin. So if you put x is equal to 0 in that, we get limit is equal to 0 in the right hand side. So log of L is equal to 0, so L will be e raised to 0 and that is 1. So answer is 1 here. By putting x is equal to 0 here, the limit will be of sin x upon cos square x. So here, this one sign with this sign get cancelled, we get L is equal to 0. See, when you simplify this limit x tends to 0, cosec is nothing but 1 upon sin cot square, that is cos square upon sin square. So this becomes sin square x multiplied by this sin x into cos square x. So one side with this side get cancelled. Sin 0 is 0, cos 0 is 1. So this is 0 by 1, that is 0. So answer is 0. Right hand side value is 0. So L will be e raised to 0 and that is 1. So limit of this problem is 1. Okay. The next question can be simplified in the same manner. That is, if you take limit x tends to 0 of 1 by x raised to 2 into sine x. Okay. First of all, check the form by putting limit x is equal to 0. If you put here 1 by 0 raised to 2 into sine 0. 1 by 0 is infinity and sine 0 is 0. So 2 into 0 is 0. So form is now infinity raised to 0 form. Now how to solve this? Take L is equal to limit of this function. Then in the next step, taking logarithm of both sides. So if you take log of both sides, we get log of L is equal to limit x tends to 0 of 2 sine x multiplied by log of 1 by x. Now sine 0 is 0, log of 1 by 0 that is infinity. So this is 0 into infinity form. Okay, by putting x is equal to 0, this becomes sine 0 and 1 by 0 that is infinity. Okay, so 0 into infinity form. Now this can be converted into 0 by 0 or infinity by infinity, writing this function sin x in the denominator. So this becomes log of 1 by x divided by 1 by sin x. Now 1 by sin 0. Sin 0 is 0, 1 by 0 is infinity. So this is infinity and this is log of 1 by 0. That is again infinity. So now the form is infinity by infinity. And now you can apply L'Hospital rule. For this log of 1 by x, what we can write? In the next step we write 2 limit x tends to 0. Log of 1 by x is nothing but minus log of x divided by 1 by sin x. That is cosec x. Okay. See here, this is log of 1 by x, that is minus log x. Why? Since log of 1 by x, using the property of logarithm, this can be written as log 1 minus log of x. Log 1 minus log x. Log 1 is 0, so this is 0 minus log of x, so this value is minus log of x. Okay? So numerator, log of 1 by x, but minus log of x divided by 1 by sin x, that is cosec x. Now, take the derivative of numerator and denominator function and then apply the limit. See here. This is 2 into limit x tends to 0 of derivative of this log x function. Constant is minus 2. Minus sign here. Minus 2 into log of x. Its derivative 1 by x. Derivative of cosec x minus cosec x into cot of x. So this is minus 2 into, if you apply the limit, 1 upon cosec is nothing but sin x. So this is sin x. Minus minus, that become plus. This minus 2 into minus 1, that become plus 2. Limit x tends to 0 of 1 upon cosec, that is nothing but sin. And cot, cot is nothing but cot upon sin. So sin into sin, that becomes sin square 1 x into cos of x. Okay? This is divided by. So 1 upon x into cot, cot is cos upon sin, so cos into x and multiply by sin into sin, that is sin square x. So you can find out the limit by putting x is equal to 0, so this becomes 0, sin 0 is 0 and here cos 0 is 1 but x is 0, so 0 into 1 is 0. So again it is occur in 0 by 0 form. Again we are getting here 0 by 0 form, so we will apply L Hospital rule to get finite limit here in the right hand side. So again by using L Hospital rule, we find out the derivative of numerator function. So derivative of this sine square, that is 2 sine x into derivative of sine x, that is cos of x, divided by derivative of this denominator function with respect to x. So using product rule here, UV rule to differentiate this with respect to x. What will be the derivative? U into v dash x into minus sin x plus v into u dash cos of x into 1, and then apply limit. So this is 2 into limit x tends to 0. Okay. Now the value, so here log of L is equal to 2 into, if you put the value x is equal to 0, 2 into 2, that becomes 4, multiply by sin 0 into cos of 0. Sin 0 is 0, cos 0 is 1, divided by sin 0, 0, x is 0, plus cos 0 is 1. So our answer is 4 into 0 by 1. So answer is 0. Right hand side value is 0. So 0 equal to log of L. 0 is equal to log of L. So L will be e raised to 0, and that is equal to 1. So our question is this, its limit is 1. Answer is 1. Final answer is 1. Because after solving this right hand side, we are getting 0 value, that is b. So log of L is b. So L will be e raised to b, e raised to 0, that is 1. Okay. So in this way, we can solve the problems of infinity raised to 0 form. Okay. And now the last form is remaining, that is 1 raised to infinity form. Last problem, 1 raised to infinity form. 1 raised to infinity form. Question is cos x raised to 1 by x, limit x tends to 0, cos x raised to 1 by x. Now in this, if you put x is equal to 0, this becomes cos of 0 raised to 1 by 0. What is the value of cos of 0? That is 1. And 1 by 0, that is infinity. So the form of this problem is 1 raised to infinity form. Okay? Cos 0, 1 by 0, infinity. So this is 1 raised to infinity form. Now how to solve this? So let L is equal to limit of this cos x raised to 1 by x. In the next step, take logarithm on both sides. So taking log on both sides. So after taking log, we get log of L is equal to what? Limit x tends to 0 of 1 by x gx into log of fx. That is log of cos of x. 1 by x into log of cos of x. Now, if you put the value of x is equal to 0, 1 by 0, infinity, cos of 0 is 1, log of 1 is infinity. Log of 1 is 0, so this is 0 into infinity form. Okay. 1 by 0 ये infinity हुआ, ये log of 1 हुआ, log of 1 0 है, 1 by 0 infinity है, so ये 0 into infinity form हुआ. Okay. So we will write this function, keep the log function in numerator, shift the second function in denominator. So already it is in denominator, so we will write this in this way, x tends to 0, log of cos of x as it is before divided by, already x is there. Okay, you have to write this function gx in such a way that after writing this function in denominator, your question will remain same, your function will remain same, there will be no change. So this log of cos x is divided by x, you just write here log of cos x divided by x. It is, if you write here it is divided by 1 by x, then it will be multiplied by x. But in problem, this function is divided by x. So we write this is divided by x. Okay. And now see the form of this problem by putting x is equal to 0. This becomes cos of 0. Cos of 0 is 1 and log of 1 is 0. And if you put x is equal to 0, this is 0. So now problem is in 0 by 0 form. So you can apply L'Hospital rule. Using L'Hospital rule, we will find out derivative of numerator and denominator function. So by using L'Hospital rule, we get log of L is equal to limit x tends to 0 of d by dx of log of cos of x divided by d by dx of x. Take the derivative of numerator and denominator functions. So this is log of L is equal to limit x tends to 0 of derivative of log of cos of x, that is 1 upon cos of x. Log x derivative 1 upon x. So according to that, it is 1 upon cos x into derivative of cos x minus sin x. And divided by derivative of x with respect to x is 1. Now if you put x is equal to 0, we get log of L is equal to, here you will put x is equal to 0. This becomes minus sin 0 divided by cos of 0. Now cos of 0 is 1, sin 0 is 0. So right hand side value is 0. Okay. So we get log of L is equal to 0 and therefore L will be e raised to 0, that is 1. Okay. Right hand side value is b. b is equal to 0. So log of L is equal to b. So L will be e raised to b, e raised to 0 and that is 1. Okay. So answer of this problem is 1. And the last one, next problem. Evaluate limit x tends to 0. Evaluate limit x tends to 0. A raised to x plus b raised to x upon 2 raised to 1 by x. A raised to x plus b raised to x divided by 2 raised to 1 by x. So this is the given limit. Now if you put x is equal to 0, what will happen? This becomes a raised to 0 plus b raised to 0 divided by 2 raised to 1 by 0. Now a raised to 0, any number raised to 0 is 1 plus b raised to 0 is 1 divided by 2. Raised to 1 by 0 is infinity. Now 1 plus 1 is 2, 2 with 2 get cancelled. So this is 1 raised to infinity form. Okay. So we identify the form of this problem, that is 1 raised to infinity form. This is 1 raised to infinity form. Now how to solve this? So let's assume that L is equal to this limit a raised to x plus b raised to x upon 2 raised to 1 by x. Now in the next step, taking log of both sides, we get log of L is equal to limit x tends to 0 of 1 by x into log of a raised to x plus b raised to x divided by 2. Okay. Now 1 by 0, that is infinity, and if you here put the value of x is equal to 0, this becomes 1 plus 1 2, log 1 is 0. So this is 0 into infinity form. Okay. So here we write the second function gx, that is 1 by x, in such a way that you will get same function in numerator. So log function as it is in numerator, a raised to x plus b raised to x divided by 2, and whole term is divided by x. See that function will not change here, divide by x. This log function is divided by x. Now see the form by putting x is equal to 0, this becomes log of 1. Log 1 is 0 and x also tends to 0. So this is now in 0 by 0 form. Okay. So if it is 0 by 0 form, now we will apply L'Hospital rule, and according to that we have to take derivative of numerator as well as denominator function. So d by dx of log of a raised to x plus b raised to x divided by 2 and whole term divided by d by dx of x. With respect to x, we will find out the derivative. Now, see here. Log of L is equal to what? Limit x tends to 0 of derivative of this function, log function, derivative of this log, that is 1 upon x. So this is 1 upon a raised to x plus b raised to x divided by 2. Derivative of log x, this is 1 by x. So this is 1 upon, if you are in whole term is x. So derivative of log x is 1 upon x, that is 1 upon this term, a raised to x plus b raised to x upon 2. Into what? Into derivative of this term with respect to x. Okay, into d by dx of a raised to x plus b raised to x divided by 2. Now this half is constant, so it is d by dx of a raised to x plus d by dx of b raised to x. Now what is derivative of a raised to x? That is a raised to x into log of b. What is derivative of b raised to x? B raised to x into log of b. So this is the derivative of log function into derivative of this function with respect to x is this. Okay, so we will multiply this by half into log of a into a raised to x plus log of b into b raised to x. Okay, and divided by derivative of x with respect to x, that is 1. Okay. Is it clear this step? Just we use the formula for derivative of a raised to x. A raised to x into log of a. Okay. And now simplify this. So this becomes limit x tends to 0 of
नहीं कोनो मैसेज आले मैम
1 upon this term, a raised to x plus b raised to x upon 2. This is divided. That is same as multiply by 2 upon a raised to x plus b raised to x. And divided by this 1 by 2 into a raised to x into log a plus b raised to x into log b. Okay. And now see here, this 2 with 2 get cancelled. Whatever is the remaining term, in that you will apply the limit. X is equal to 0, so by putting x is equal to 0, this becomes a raised to 0 plus b raised to 0. Okay. Here in numerator, a raised to 0 log of a plus b raised to 0 log of b. Now a raised to 0 is 1, b raised to 0 is 1. So this becomes 1 upon 1 plus 1 into log a plus log b. So this is equal to half into log of. Use the property of logarithm, log a plus log b, that is log of a into b. Okay. So this is log a, log ab into half. Again, you will use the property of logarithm. This can be written as log of ab raised to half. Okay. Log of ab raised to half, that is nothing but log of square root of ab. Because you know the property of logarithm, log of a raised to b is nothing but b into log of a. So using this, log of ab raised to half is nothing but half log of ab. So this raised to half means square root of ab. But this is equal to what? Log of L is equal to log of root of AB. Okay. The left hand side is our log of L. So equate this with log of AB. This is not our answer, log of AB. We will equate this with log of L. And see here, this log with log get cancelled from both sides. So we get L is equal to what? L is equal to square root of AB. So L is equal to square root of AB. This is the answer of this problem. Limit of this question is square root of AB. Okay. So in this way we can solve the problems of 1 raised to infinity form. The procedure for solving the three form 0 raised to 0, 1 raised to infinity and infinity raised to 0, that is similar. So use the same procedure for solving the problems of these three forms. If the question is in this form, then taking logarithm, it will convert it into 0 into infinity form. Then writing the function gx in denominator, it get converted into 0 by 0 or infinity by infinity form. And then by using L'Hospital rule, you can evaluate the right hand side limit. If it is b, then log n is equal to b, so l will be e raised to b. Okay. So in this way, we can solve the problems of the three indeterminate form. Okay. So this completes our first unit. In the first unit, we studied the three main theorem, that is Rolle's, Lagrange's and Cauchy's mean value theorem. Then in second part, we study the expansions of the function using Taylor's as well as Maclaurin's theorem. And in the third part, we evaluate the limit using the indeterminate form with the help of L'Hospital rule. Okay. So we take maximum lecture on our first unit to get your concept clear. And now from the next lecture, we will start with our second unit. Okay. So all the topics in the first unit are completed. So now in the next lecture, we will start with our second unit, that is Fourier series. Okay. So is there any doubt or difficulty regarding this?
No, ma'am.
Okay. So you can leave the meeting now. Lecture is over. Okay.